Sorry, what?
I'm just gonna read it off, trying to save the rest of it. Alrighty. Everybody set? Everyone set? The answers are as follows. Number 1, answer's 10. Hopefully that didn't stress anybody out.
That was the easiest one. I was like, he's like, hopefully I think the first one's the easiest one. 10. I was like,
You're not gonna believe what it is
the
today.
actual thing. Is it the real test?
I need to change question number 1 on the real test.
No. What is it? Radical one?
Wow.
Is it radical one? It doesn't matter. It's not like we didn't know. I got that anyway. Wait, okay, if you would have got radical when you said that. We should like have a
Oh, I didn't want to do that. Yeah, that's a good news. No. Sorry, I'm supposed to Okay, here's the real one. Okay. The first answer should be 6.
Good.
Number 2, 5 radical 5. I'm not right here. Number 3, 7 radical 6. Number 4, 7 radical 5. Number 5, 4 radical 7. Number 6, 8 radical 2. Number 7, radical 210. It does not reduce. Yeah, I suppose you can call it prime. Just rewrite it. Solution is when you get x equals something. So I would just say leave it as is. Don't leave it blank. Don't leave it blank. I suppose if you put prime, I'd accept that. But the best answer is radical 210. Max. That's fine. Yeah. As long as you don't leave it blank, and as long as you say it stays the same, I'm okay with that. Number 8 is a little tricky. 6k squared radical 7. 6k squared radical 7. Okay, you can do that. I would put parentheses around radical 7 to make absolutely sure it doesn't look like the stuff's inside. I love that. Sorry.
6 radical 7 and then x k squared is not.
If you do this, some people are asking if you do this. Is that allowable? I would like you to do this. To make absolutely sure that the k squared is not under the radical. Because if it's snug up against, it can look kind of confusing. Sorry.
Why does the k squared have to be not under the radical? Because I did 6 radical 7 k squared all under the radical.
Oh, because you started with radical k to the 4th.
Yeah.
You already simplified it to regular k squared. Just like radical 64 simplifies to the number 8, but not the radical 8. All right, where was I? Oh, that was number 9. Okay, number 8. Any repeats up to number 8? I just read number 8. That's number 8. All right, next page. Number 9. Negative radical 6 plus 6 radical 3. And if you have that backwards, that's fine. If you have 6 radical 3 plus negative radical 6, that's fine.
What if I did 6 radical 3 minus?
terms. Negative radical 6 plus 5 radical 2 plus negative 2 radical 5. So there are only 2 like terms in the whole thing. Yeah.
I had 17.
That'd be right. Yeah,
Well, not
3 terms for number 10. And again, these 3 terms can come in any order, just make sure the negatives belong to them. Negative radical 6 plus 5 radical 2 plus negative 2 radical 5. Excuse me.
Oh, you said they could come in any order, right?
Correct. Correct. As long as the negatives belong to the 2 radical 5 and the radical 6. So don't put negative 5 radical 2. Number 11, there are 2 terms. 3 radical 3 plus 9 radical 2. That is again, 3 radical 3 plus 9 radical 2. No, psych this out now.
Wait.
Yeah,
3
okay.
radical 2 plus 3 radical.
3 radical 3 plus 9 radical 2. Okay, gotcha.
How can
Well,
radical 18, or I mean, how can radical 18 be 9 radical 2?
it is not. It combines with something else. Radical 12 turns into, well, actually, just a second. Well, let me show you. 3 radical 18. I was going to go through it a little bit, but take a look up here. Radical 18 is radical 9 radical 2. 3 times radical 9 times radical 2 is 3 times 3 times radical 2, which is 9 radical 2. Okay. Now, hold off on the other specific questions until we get through the whole thing. That was number 11?
Yep.
Number 12, there are 3 terms. Negative 5 radical 3 plus negative 2 radical 2 plus negative 2 radical 5. Number 13, you distribute. You do need to simplify when possible. The final answer should be 12 radical 2 plus 16 radical 30. Number 14 has 2 terms. 2 radical 3 plus radical 6. It really wasn't any simplifying, except multiplying. And it repeats up to number 14. Ready? Next page. Listening. Number 15. Ahem. Chit chat later. Lady. Waiting. Okay. Number 15. Radical 3. Number 15, the answer is radical 3. Number 16, the answer is 5. 17, the answer is radical 5 over 8. Number 18 is messy.
Yeah.
The top is 2 terms. 3 radical 26 plus negative radical 39. The bottom is 52. 52, correct. This is after you simplify. Yeah.
Can you repeat the top of?
Yeah, the top was 3 radical 26 plus negative radical 39. And again, the bottom is 52. Number 19 is a fraction. The top is 3 plus radical 5. The bottom is 2. Yeah.
Can you repeat that?
Yeah, 3 plus radical 5, all divided by 2. Number 20, hold on to your hats, there are 4 terms on top.
Holy what? Yeah.
That's the one.
25 plus negative 10 radical 5. You might want to start writing this down, it doesn't agree with you. 25 plus negative 10 radical 5 plus negative 5 radical 2 plus 2 radical 10. All divided by 5. If that doesn't agree, do we need to repeat it?
Oh my gosh. Can
Can
you
you
just,
repeat step number 20?
what was it, 10 radical what?
It was 25 plus negative 10 radical 5 plus negative 5 radical 2 plus 2 radical 10. That's on top. on the bottom of the file. Everybody get it? Repeat? All right, move to number 21. Solution P equals 0. P equals 0.
Equals 0.
Yep, okay.
Number 22. N equals 100.
Oh.
Number 23. N equals 2. And that's the only solution. Number 24. There are two solutions for number 24. M equals 10. M equals 2. And number 25, the restrictions, x is greater than or equal to 13 over 18.
Wait, what?
X is greater than or equal to 13 over 18. Yeah, great. Okay. Good, go on.
Can you repeat 21?
21, yes, P equals 0.
Wow.
And it repeats up to number 25. Extra credit, number 26. Write them in, please. The simplified version is negative 48. Everybody listening?
Yeah.
Negative 48a squared times radical 6b. Negative 48a squared times radical 6b. So, okay. Extra credit number 27. You have 4 terms. There should be no fractions.
I have 2. I have 1.
Negative 2 plus 2 radical 3 plus negative radical 2 plus radical 6.
Yes.
Anybody want that again?
Yes, please.
Okay. Negative 2 plus 2 radical 3 plus negative radical 2 plus radical 6. Very good.
I have, the opposites of all those over negative terms.
Oh, that's true, that's correct, but that's a simplify. Yeah, yeah, good. Negative 2 plus 2 radical 3 plus negative radical 2 plus radical 6. That's for number 27. Adam. 26, yeah. Negative 48a squared times radical 6b. And number 28, there is only one solution, n equals 10. Any other solutions are extraneous? No, that's a fancy word for junk. Any repeats on the whole thing? All right. Time for, let me erase this real fast. So I have plenty of room. Questions? Okay, follow the line. Go.
Okay, so I got 25 right, but can you give like another example of
Yes. I'll do one off the top of my head. So 25, I'll just put this in quotes. Let's just say you have a radical, and I'm just going to make this up. 93x minus 17. The thing you have to remember for radicals is that the stuff inside cannot be negative. It has to be 0 or above. Here's what I'd write. 93x minus 17 is greater than or equal to 0. That's the key. And then just solve. So 93x greater than or equal to 17, divided by 93 on both sides. And you should get x equal, greater than or equal to 17 over 93. Yeah, very good. Oh, wait a minute, Elijah.
That was actually, number 25 was actually the one I wanted to do, but never mind, I got it.
Okay, yeah. Okay.
I got x equals
So which problem is that?
25.
Okay.
X equals 13 over 18. But I don't know how one
Has to be greater than or equal
use
to.
greater.
Oh, remember, greater than or equal to means it's 0 or above. The reason I'm doing 0 or above is that I don't want it to go below 0. Anything 0 or above is okay. So that's why I use greater than or equal to. CC the next.
Can you do number 18?
18, yeah. Oh yeah. 3 radical 2 minus radical 3 4 radical 13. There are two right ways to do this. Keep in mind, this is not a hostage situation. Hostage situation is when it's 4 plus radical 13. If it's an innocent looking number added to something that's a radical. So there are two ways you can do this. The most intuitive way is to multiply top and bottom by 4 radical 13. There is another way. As long as it's not a hostage situation. By the way, if this is confusing, don't worry about it. Don't do it. But theoretically, you only have to multiply by radical 13 over radical 13. Either one of those should work. It's not a hostage situation, so you don't have to do 4 plus or 4 minus. Let's just do the big huge one. Distribute this. Number times number, 12. Radical times radical, radical 26. Still okay? And then minus 4 times radical 39. All over 4 times 4 is 16 times radical 13 times radical 13 is 13. Okay? 16 times 13 is kind of gross. So it's 100, 30, 60, so 190, 208, I think. 12, radical 26. Did anybody have that, just out of curiosity? Okay, never mind. Look for GCF, look for factoring. Is there one? Now, by the way, with GCF, you do not have to pull out anything from the radicals unless it's a perfect square. No.
You could factor it by DCF.
So what's the GCF?
4.
4, correct. So this would be 3 radical 26 minus radical 39. And then on the bottom is 208. 4 actually goes into that. 4 and 208 reduced to 1 and I think 52. All right?
Yep.
So you're left with 3 radical 26 minus radical 39 over 52. And that's it. Oh. Okay. Does that make sense? Again, if you want to see the shorter version, I'll just turbo this. This is going to be 3 radical 26 minus radical 39 all over 4 times 13, which happens to be 52, and you're done. Now again, if you don't remember that in non-hostage situation you only have to multiply the radical over radical, don't worry about it. It works just as well if you do the other way, it just takes a while. Yeah.
Can you
And then-
remember 15?
15? 1, 5? Yeah, 2 radical 12 over radical 16.
I did, I changed radical 16 into 4, and then that
Correct.
left 2 radical 12 over,
Over 4.
yeah, and then I reduced 2 and 4.
I would reduce this radical first. What perfect square is hiding in there? Yeah, radical 4 times radical what?
3.
3. So what this is this is really 2 radical 2. So it's 2 times radical 3 over 4. And this 2 times 2 on the top is 4. And then the 4's cancel. And you're left with radical 3. Okay.
Will we be able to use calculators?
I would not count on it. Expect not to use calculators on this particular test. Yeah. 26, that's an extra credit? Okay. That's pretty short, I can do that. Number 26. So let's see. Negative 8 radical 216. A to the 4th b. Now, are there any perfect squares in that radical? It's a little hard to see. 216 What do you think goes into 216? Yeah,
4.
4. That would definitely work. Radical 216, I'm going to do this off to the side. Radical 216 is radical 4 times radical what? There we go. 54. Are there any perfect squares in 54? Yeah. 9. Radical 4 times radical 9 times radical 6. What is that really?
6 times radical 6.
Yeah, 2 times 3 times radical 6, which is 6 radical 6. So this number part, remember, a radical can split up like this. If you want to be absolutely technical, radical 216 times radical a to the 4th times radical b. You can split all the radicals into pieces as long as they're multiplied. This is negative 8 times 6 radical 6 times, does anyone know what this is?
A squared.
It's a squared. How do you get that?
It's like the 1/2 thing.
You do the half power, right. If you have like radical a to the 10th power, it's a to the 5th. A lot of people go, this is an unfortunate example because people think, oh, you square root 4 and you get 2. You do not square root the power. Like I didn't square root this, that would have been 3 point something. You cut the power in half. The radical b doesn't change. So what I'm going to do is I'm going to multiply these numbers together. Negative 48. I like to put the non-radical stuff first. So scoot the a squared up in front. And then radical 6 times radical b is radical 6b. That's it. Question?
Why do you have to multiply with radical
It's considered neater to have everything under one radical than have a bunch of teeny radicals scattered around. Is that what you're asking?
No.
Radical 6 times
Why
radical
do
b?
you need? Oh. I see now.
Okay. Next. Yeah, sorry. I need my towel.
19.
19, just a second. 2 over 3 minus radical 5. Yeah, that's a hostage situation. 2 over 3 minus radical 5. 19. And then they tell me the cure for a hostage situation. Bell. But a conjugate, nice word. What is the conjugate of this thing? 3 plus radical 5. Make sure you don't try 3 minus radical 5. It will not work. What do you get on top? Oh, now people. Go.
6 plus 2 radical 5.
Right, you have to distribute. 6 plus 2 radical 5. And then the bottom. Okay.
You get 3 times 3 is 9. And radical 5 times, negative radical 5 times radical 5, which would be negative, or negative 5.
True. What happened to the other two? Outer and inner.
Oh, right. So, yeah, so you do 9, and then you do 3 radical 5, and
Good.
then you do negative 3 radical 5, and then you do negative 5.
Minus 5. Everybody see why this is regular 5? Radical 5 times radical 5 is 5. What else happens? Like it.
The 3 radical 5s cancel.
Yeah, plus 3 radical 5 minus 3 radical 5 cancel. What does that up to?
Is 4.
4. 6 plus, what am I doing? 6 plus 2 radical 5, I'm sorry, go ahead.
There's a DCF on top of 2.
There is. Pull it out for me.
2, in parentheses 3 plus radical 5.
Good.
And the 2 and 4 can cancel.
Correct. The 2 and the 4 reduced down to
1 and 2.
1 and 2. Final answer should be 3 plus radical 5 all over 2. This is kind of an interesting problem. A 2 over 3 minus radical 5 is now 3 plus radical 5 over 2. It almost looks like a reciprocal, but it's not. That's a complete accident. That's kind of like, 1,000 leaves fall from the sky and they all pile up into it. Pile like yay big. It's just like that. It should creep you out. Not that much. But I don't know if Lisa actually did that, I would be freaking out. Yeah. Everybody got number 19? Number 20. 5 minus radical 2, or 5 plus 2 radical 5. Let's do it here. Number 20. Over, I forgot what minus means. Oh, it's 5 minus radical 2. 5 plus 2 radical 5 on the bottom. Is that right where you have a 5 and a 5 both on the front? Okay. So, next.
You want me to start?
Go for it.
Okay, so you multiply it by -5 plus,
You could. -5 plus 0. It's easier to switch the sign in the middle.
ah,
Either way will work. It will work if you. By the way, don't switch both of them. If you switch both of them, it will not work. But if you just switch the 5, that should work.
okay, let's do whatever's easier, I guess.
Okay.
Alright, 5 minus 2 radical 5,
Uh-huh.
off 5.
Correct. Everybody see that so far? Hostage situation. So switch the sign and keep the rest the same. That's called the conjugate. Go for it. How do you do the top?
4,
Foil.
right.
Go for it.
Okay, so, you have 25,
25.
it would be -10 radical 5.
Minus 10 radical 5.
Minus 5 radical 2.
Okay.
Oh, right, it would be 2 radical 10
Plus or minus?
plus.
Plus, yes, 2 radicals 10. Radical 10 is a radical is a radical. Now comes the bottom. Take over, Ethan.
25,
Okay?
minus
Uh,
10 radical 5,
good.
plus 10 radical 5,
Okay?
and plus minus
Minus.
4 radical 25,
Yes. Now help me out with this. What is radical 25?
5,
It's 5. So 4 times radical 25 is really 4 times 5, which is better known as
20.
20. So take over, Titus.
Uh,
Anything else simplify?
You can simplify it, wait, you can cancel 20 to 25.
I wish.
Oh, wait.
Yeah, these don't cancel, these don't cancel. They're so tempting if they get you behind these statements attached to something else. So there is, yeah.
We can cancel the -10 radical 5.
These two cancel, because plus and minus will cancel. Keep going. What's left on the bottom?
25 and 20
25
minus,
minus 20, which is better known as
5.
5. The bottom is 5. So we've got, here's what I have so far. 25 minus 10 radical 5 minus 5 radical 2 plus 2 radical 10. Good question. Do any of those radicals reduce? I don't. What's that? Do any of these radicals reduce? Is there a perfect square in any of them?
No.
No. So what do you do?
Leave them.
Leave it. You're done. What you could do is if you split it up, you could do 25 over 5 plus -10 radical 5 over 5 plus -5 radical 2 over 5. This is actually what I would do, but I won't require it. 2 radical 10 over 5. This boils down 5 plus -2 radical 5 plus -1 radical 2 plus, and this one you're just stuck.
Oh my god. Wait, do you wanna?
That's also, I'll accept either one of these. These two circle things, take your pick. The one on the bottom is technically better, but I'm not requiring it just yet. That's the reduce all the way version. but you split it up. So dividing the whole thing by 5 is the same thing as dividing each one by 5. That's what I did here. And then if you do that, the little pieces, a lot of them reduce. Next. Any others you want to see dissected? Yeah.
9.
One second. Number 9, let me look. Oh yeah. Does everybody get on the stuff on the board so far? Right. 3 radical 6 minus radical 6 plus 3 radical 12 minus radical 54. First of all, I would go through and see if you can reduce term by term by term. Is there anything that reduces in here? No, so just leave it. Anything here? No. I would do one little thing now. Put a 1 in front. That might help you see the like terms here. What about here? Yeah.
Yeah.
What about it?
It reduces to.
Yeah, 3. What does radical 12 split into?
4.
Yeah, radical 4, radical 3. So this is 3 times 2 times radical 3, which is 6 radical 3. Okay. What about this monster?
Yes.
Go for it.
It splits into radical 9, radical 6.
Good. What is that really?
3 radical 6.
Plus negative 3 radical 6. So let me copy this down. 3 radical 6 plus negative 1 radical 6 plus 6 radical 3 plus negative 3 radical 6. Does anybody see anything that happens? Go.
3 radical 6 plus negative 1 radical 6 plus negative 3 radical 6 no, 9 equals negative 1 radical 6.
Negative 1 radical 6 plus 6 radical 3, which is not a like term, and you're done. Okay. You could also just cancel the 3 radical 6, negative 3 radical 6. That would work too. Yeah.
Can you do 28?
28. Everybody get that one? I forgot. That was number 9. 28. Let's try it. Let's scroll down. Yes. Hang on a second. Give me smudges off of the board. All right. Who needs aerobics? N equals, this is number 28. N equals radical something. 4n minus 36 plus 8. Now remember, we did a whole bunch of things with restrictions and such. If you promise that you'll just test all your solutions at the end, you can actually skip the restriction thing for the main part of the test. Except with the exception of number 25, which asks for nothing but the restriction. So how do you do this? Well, you notice the most annoying part here is the radical. I want to get rid of it. How do you get rid of a radical? John? Square it. There's only one problem. Can you see it?
You have to get rid of
The 8 is in the way. You have permission to get rid of it first. Subtract 8. 11 minus 8 equals radical 4n minus 36. Now you can do it. Just remember, when you square, 2 things. You have to square the entire thing, both sides. And this is not a fair fight. Yeah.
On the left, it is, you have to square the first double product and square the last.
Good. What is it?
N squared,
Huh?
minus 69.
Yep.
Plus 64.
Right. Equals what?
4n minus, or so it's squared and radical cancel, and 4n minus 36.
Correct. Is that right so far? Can I solve this with algebra? Can I just start doing stuff to both sides?
No.
Why not? What's stopping us?
Because the ends,
What's that?
because the ends are almost.
Kinda, sorta. Well, that's sort of a shooting cow thing, but yeah.
There are 2 species of n.
2 species of n. If there's more than one species of N, you can't use algebra on both sides. What's the cure? You immediately have to go and get the what?
One side down to 0.
Get the answer down to 0. How?
You would subtract 4n and
Okay, as
on
long
both
as you do
sides,
it to
both
both
sides,
sides.
and then add 36 to both sides.
Add 36 to both sides. Let's see what happens. What do you get?
N squared
Oh,
plus negative 20
plus negative 20
plus n
and plus,
plus 36. I don't know.
do that. 100
Oh, okay, add, sorry.
equals, cancel, cancel, and you make
0.
0. Is that right so far? Does that thing factor? Go. Yeah. N minus 10, N minus 10. What solutions do you get? How do you solve this monster? Go.
You would take the two parentheses,
Uh-huh.
put them into their own equations, but since they're the same thing, it doesn't really matter.
Right. But you set them both equal to
0.
0. Good. And you're right. Add 10 to both sides, you get n equals 10. And you get a duplicate over here. You do not have to write it twice, although it won't hurt you if you do. This is your solution. N equals 10. And remember, it wasn't a verified? Check it. So the original one was n equals radical 4n minus 36 plus 8. Question, what if I plug it in and it comes up false?
Then there is no solution.
Then there's no solution, because this was the only option we had. Let's try it. 10 equals the radical of 4 times 10 minus 36. And then plus 8 in the end. What's this?
2 plus 8, which is 10, and 10 equals 10.
Hold on. Hold on. This is 40 plus minus 36, yes. And radical 4, which is 2 plus 8. And sure enough,
10 equals 10.
yes.
Yeah.
So you're good to go. Questions? Next. Any other ones? How did you do on page 1? Where you were reducing plain old numbers? The radical, do you notice where they pulled out a 7? That means that radical 49 was in there, and that can be hard to see. You can. I will show you one little trick on that. For example, I'm going to give you radical 98. Radical 98 can be a little tough to see. 4 does not go into it. 12, well, it's not a perfect square anyway. 9 doesn't go into it. 16, unfortunately, does not go into it. Here's a trick, though. Here's a trick, though. Does 4 go into that thing? Let's test it.
Yes.
First of all, oh yeah, quick test. Does 3 go into it?
No.
How do you know?
You add the numbers.
Yeah, what's 9 plus 8?
17.
17. Does 3 go into that?
No.
No. So 3 doesn't go in. Does 4 go in? Let's test it. 98 over 4. 4 goes into 9 twice with a 1 left over. Then the 4 goes in 18.
No.
Yeah, it goes in 4 times, but it goes in, yeah, that's not going to be even.
Yeah.
In other words, it doesn't go in evenly. I want to know if 4 went into it. The answer is no. Here's a question for you. If 4, yeah, if it were 96, it would have worked. 98 is halfway between 96 and 100.
49 times 2.
Yeah. Now then, quick question. Let me just catch up further.
No, that's a lie.
Huh.
We know some.
If 4 doesn't go in, would 16 go in?
No.
No. You can save yourself some work. You notice, did 3 go in here? No. So is 9 going to go in? No. So if a smaller number doesn't go in, then all of its multiples, you don't have to bother. They won't go in. So you can save yourself, there's no such thing as a 9 going in or a 16 going in. 25 definitely doesn't. 36. Any question if 36 would go into that? Did 3 go in?
No.
Then 36 won't. Yeah.
Can we just modified two.
You could. What would you get?
Radical 2, radical 49, and the simple.
By the way, yes, that would probably flush this out right away.
Yeah.
That's actually kind of accidental. If it works, it works. Great. Because I'm thinking of like 245. It's a little harder. Like what you'd probably do there is let's see what happens if we divide by 5. But a lot of people would say, why waste my time dividing by 5? 5 is not a perfect square. Now, there's two answers to that. Number one, you're right. 5 is not a perfect square, and it's not going to reduce. But if 5 goes in, if you just don't know what goes into it, try dividing by something that works, and maybe you'll get lucky, like this. But let me step through this. You said that 3 didn't go in, so 4 doesn't go in. That means 12 doesn't go in. 16, 9 doesn't go in. 25 doesn't go in. 36 will not go in because 3 didn't. What's the next perfect square? 7, 49. Here's a question for you. Does 49 go into here?
Yeah.
Yeah. It's not as easy to see though. Here's one last trick. 98 divided by 49, you'd have to just do it off to the side. 49 times 2, see what happens. Does 7 go into that?
Yeah.
This is one of those, why waste your time with 7? 7 goes into 9 how many times? Once. With 2 left over? 7 goes into 28? 4. 7 goes in 14 times. So what this really is radical 7, radical 14, which seems like a complete waste of time.
Yes.
Look at this stuff.
But that also is seven.
This makes what?
7.
Yeah.
Radical 49.
Radical 49, which
Yeah.
turns into 7. Ta-da. That's another, this is a sneaky way to do it. You don't have to do it that way. But if you have a stubborn reducing problem, start breaking off pieces and see if you can find pairs. Let me just show you, I'll just show you one quick thing off the top of my head where it should work like that. How about this? Radical 2,880.
Wow.
Okay.
Now that's more intense than the test is going to give you. But if you can do this, you can do the test.
4.
Maybe 4 goes in. What's that?
100.
100, it would have to be a 0, 0.
9.
But right, dude, 10, by the way, 10 goes in.
9.
Would 10 be a waste of
Nine.
time?
20.
Depends on the point of view.
20. Yes, it would.
Hold on a second.
Well, about 9.
Here's my question. If you get, let's pretend you get stuck.
9.
Let's just say I can't think of a single perfect square. Your brain freezes and you don't realize 4 goes into that.
Try a couple.
Let's just try 2.
20. Tons. Radical 2.
Sometimes you get lucky. Does anybody see anything interesting in here?
It's 144. 60 squared.
144 times what? 10. So what is this again?
12.
12 times radical 2 times radical 10. Are you done?
No. Keep going.
Smash these back together. Oh, somebody asked. Do you have to multiply these back together?
Yes.
Yes.
Yes, you do. There's a reason for that.
And then you pull out radical 4, radical 5, so you get
Yes.
radical 5,
And then it's 60.
If you just hold it. Easy, my friend. Land your plane safely. Now, if these don't look good, mush them together. This is radical 4, radical 5. It goes down one more time. This is 12 times 2, like you said, radical 5. So it's 24 radical 5. That's one way to do it. I'll show you one last way to do it. Let's just say you forget about that trick of mushing them back together. Well, keep taking it apart. 12 radical 2, and then radical 10 splits into radical 2, radical 5. You might think that's a waste of time. What does that make?
2.
That's another way to get the same thing.
No, we don't.
In other words, explore. You will not break a problem by playing with it. You can explore. Excuse me. Let me say it again. You cannot break a math problem by playing with it. That's very empowering. That means you can just, especially if you have a few minutes to spare, and you're looking at this and you say, what is this thing? Well, try this.
That's gotta be very.
It is not, actually.
Oh,
I deliberately picked one that was not.
two.
The very first thing I would do is 2. You could try 4. 4 might go into that thing. And 4 would be a perfect square. Yeah, let's try 4. Like this one.
Well, I mean, I have a feeling the four would be short.
Radical 4, radical what? I don't know. Yeah, no. I was trying deliberately not to say that. Hold on a second. 4 goes into 5 one time with 1 left over. 4 goes into 12.
Three.
3
Two left over.
with nothing left over. 4 goes into 4. 1. 4 goes into 2.
Zero.
Good. Fill in a 0. 4 goes into 28.
7.
7. 4 goes into 8.
2 times. Wow, I took perfect.
It's still nasty. I agree.
Oh, man. It's even worse. What the heck?
It's smaller.
But it still looks worse.
It does.
It looks more odd.
Would another 4 be buried in there?
14. No, just put 2 in. 14.
Try 4.
No.
If it doesn't work, we can always do 2.
14.
4 goes into 13
Three. One left.
3 times with 1 left over. 4 goes into 11.
Two.
2 with 3 left over. 4 goes into 30. 7 with 2 left over. 4 goes into 27. 6 times is 24 with 3 left over. 4 goes into 32.
Eight. Even.
Perfect. Oh, we have to do it again now.
See this? You can keep pulling 4s out of this. As it turns out, it'll do this. I'm going to speed this up.
Oh.
Yes, please. Yes,
So you knew all along?
See, trick
How many 4s are there?
a lot
Oh
of
my gosh.
Let me see. 1, 2, 3, 4.
So it's 16 right now. I can't say what's happening. Radical 4, radical 4, radical 4, radical 4. Ugh.
Okay.
Too many.
Then this is 4, 4, 4, 4. There's another 4 that goes in here.
Oh my gosh.
512.
We're not done yet.
There, you're right.
Then we're not done again, and then we're not done again.
It's on camera.
128. I'm just curious if I can see something better than 4 in here.
No, I'd rather just keep doing fours. 12.
12 would be 144.
128.
Oh,
11. It goes in 11. 32 times.
3, 9,
9 doesn't go in now.
12, 15, 49.
Wait a minute. We always get up. It's 8
I don't know.
radical 2. That's 120.
There's a 64 in here.
8 radical 2. Yeah, 8 radical 2.
So this is 2 times 2 times 2 times 2 times 2
Oh my
times 2 times 8 times
Just
radical
cross
2.
the.
8, 16, 32, 64, 120, 256, 512.
What?
Radical 2.
Ew, that's horrible.
Got it.
No, terrible. Why would you
5
do that?
slash. Oh,
Just to
that's
prove.
500.
Any problem can be reduced if you pick at it. You don't move a mountain with one swing of the pick.
With the mustard seed,
You do it with a billion swings of the pick and carrying away little tiny pieces. Right. Questions? Next. Anything else?
Why are we going over that problem? We're all just gonna
Are there any problems you'd like to see variation of? Or we got stuck?
Yes.
Like
All
what?
of that.
Be specific.
All.
No, we'll do that tomorrow.
Anything from 1 to 28.
Pick one.
1.
No.
Number 1 would be a little bit of a waste of time.
6.
Yeah.
6.
Oh,
We do
listen.
We did
24. Okay. So M is radical negative 20 plus 12
No, I didn't.
I forgot what it was already.
M.
Negative 20 plus 12 M. So So this one's the number 24? Okay, everybody look up here, please. This is probably the second to last problem I'll be able to do. So, Paul, tell me what to do first. Who's feeling brave?
Not me.
We do it as a
All right.
Not feeling
Bye,
brave
go.
today.
What do you do first?
Get rid of the radical,
How?
squaring both sides.
Yes, make sure you square both sides. Is that a fair fight? No. So what are we gonna have to do at the end?
Check it.
Yeah, test all the answers. Yeah, well.
I meant like variation of 24.
Oh, sorry. You did that?
Just word it like
Let me open this up.
Yeah, that is cool. It's like baby sheep, purple and blue. Well, cause it's from the marker.
I know, but it makes it
cool.
What if that was just a white marker at the beginning, you know?
White marker?
You mean a white towel? White
Yeah,
towel.
that's what it is, Elijah.
White marker. It just turned blue. And then looking at yourself.
Hang on a second.
Yeah, I don't think so. I think it turned purple instead of, it would have turned blue. So you're
There we go.
Sorry.
I got the thing to generate a new one for us.
A generator?
This is kind of like number 24. They didn't want the exact one, I understand.
Okay, wait, what if it was your red color?
There is a little too much chit chat. You better rest.
Wait, what is it? It's purple.
Radical negative 72. This is one that's kind of like 24. Negative 72 plus 17x equals, I think, x. Yes. Talk me through it, somebody. Go, John.
I don't know what I'm doing.
Go for it anyway.
So you square,
Yes, what does that get rid of?
the radical.
Yeah. Is that a fair fight?
No.
No. Why not? Why isn't it a fair
Well,
fight?
I don't want to say it, never mind.
That is. Why is that not a fair fight?
Because that's, there, one's the square and one's the,
Right, this is a square and this is only a radical. What would have been a fair fight?
if they're both, squares.
Yeah, plus or minus if there'd been a square root. Like a full-fledged square root, not just plus, but plus minus. So, these will cancel. Negative 72 plus 17x equals what? What?
That's great.
X squared. What's your next step here?
You got to make it equal to 0.
Equal to 0. Tell me why.
Why?
Why? Yeah.
Because there's.
Why not just subtract 72 on both sides, or add
Yes.
72 on both sides?
Because there's different species.
Mm-hmm. If you have two or more powers of the same variable, you can't do stuff on both sides and expect to solve it. You gotta get the answer to 0. How? Last question to you.
Minus
There's two ways you could do it.
17x.
You can subtract 17x, and then you have to do one more thing. You gotta get rid of one more thing. This will cancel. But I want to get the answer down to 0. What's still in the way?
Oh, the 72.
72. How do you get rid of it?
Add 72.
I expect a little less. No? Hang on, just a second. Yeah, add 72 to both sides. So here's what it looks like. 0 equals x squared minus 17x plus 72. Any recommendations now? Last part of the day. Okay.
I have no idea. I'm doing.
I want to solve this thing. I can't use algebra. Two different species.
No.
Something we did an entire chapter on. Yes.
You factor it.
Factor it.
Unfoil.
Unfoil. Does it unfoil? Does it unfoil?
Yes.
8 and 9.
What's your numbers? 8 and 9 close.
Negative.
Yes. Because what's that right?
Dang.
No,
It's not.
different.
That's it. It is. One's mean and one's bad.
Hold it. I need to finish the problem, not chit chat. It's what? X minus 8, X minus 9. Does anybody know the solutions just off the top of your head? Go, Susie.
0 equals 8. I mean, x equals 8.
X equals 8, I know that.
No.
And X
0
equals
8.
9. Question.
They both work.
Hold on. Do I know for a fact that these both work yet?
Yes.
No.
Max, what do you need to do?
I was gonna say that, but anyway,
Okay,
yeah, so you need to plug them in.
right. It's not a fair fight, so you gotta test them. I'll do it really fast. This is way too loud. This is not a free-for-all chit-chat. Gotta stay plugged in. I'm glad we had extra time, but make sure you take advantage of it. Negative 72 plus 17 times 8 is equal to 8. Is that true?
Yeah.
8 times 17 is 80, 136,
Yeah.
I think.
Yep.
And this should give radical 64, which is good. The other one is radical negative 72 plus 17 times 9 is equal to 9. This is, I'm sorry? 153. And if these add up to, I believe, 81.
Yep.
Which works. And the last question. Test is tomorrow. So now's the time to ask.
Oh, no, anymore.
All right. Please stand. Church is a minute early, but it never hurts to go with the church. And let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. All right. See y'all later. Thank you.